radicals. Adding and subtracting. Let's start by reviewing what we call like terms. An example of like terms would be 4x and 5x. You'll notice that the coefficients are 4 and 5. The variable would be x. If we want to add these like terms, we add the coefficients and we keep the variable the same. Similarly, we can add or subtract radicals. In order to do this, we need like radicals. Like radicals are when the radicand is the same. The radicand is what is under the radical sign. Okay. For example, square root of 2 and 3 square root of 2 are like radicals. They're alike because the numbers underneath the square root symbol, underneath the radical sign, are the same. Both of them have a square root of 2. The 2's are the same under the radical sign. Another example would be 4 square root of 3 and negative 2 square root of 3. These are also like radicals because the radicands of 3 are both the same. We can do this also with cubed roots. The cubed root of 2 and 4 times the cubed root of 2 would also be like radicals because the cubed root of 2 is the same in both 1 times the cubed root of 2 and 4 times the cubed root of 2. What would be a non-example? The square root of 2 and 2 square root of 3 are not like radicals. You'll notice that the 2 and the 3 are not the same. That indicates that we do not have like radicals. Let's try to work some problems. We're going to simplify each expression. Let's start with 3 times the square root of 5 plus 6 times the square root of 5. You'll notice that the square root of 5 is the same in both expressions. So just like when we add like terms, we're going to add the coefficients in front of the square root of 5's. So 3 plus 6 gives us 9, and we're going to keep the square root of 5 the same. Just like in 4x plus 5x, in our very first example, we did not change the variable. Here, we do not change the square root of 5. Let's try another example. 2 times the cubed root of 9 plus 5 times the cubed root of 9. Again, we have the entire radical part is the same. So we're going to add the coefficients together outside of the radical. So 2 plus 5 is 7, and then we're going to keep the cubed root of 9 the same. What about 6 square root of 5 minus 2 square root of 5? These would be considered like radicals, both of them having a square root of 5. So we're going to keep the square root of 5, and we're going to simplify the 6 minus 2. 6 minus 2 is 4, and we're going to keep the square root of 5. Another example would be 8 times the square root of 7 minus 3 times the square root of 7. Again, the radical part is the same, so we will subtract the 8 from, subtract 8 and 3, giving us 5, and then keep the square root of 7. How about this one? 5 times the square root of 32 plus 8 times the square root of 18. At first we see that the square root of 32 and the square root of 18 are different. But we may be able to simplify each radical first and work our way towards like radicals. So we're going to simplify each radical first. We're going to look for like radicals. 5 times the square root of 32 can be written as 5 times the square root of 16 times 2. Remember, when you're simplifying radicals, you want to look for the largest perfect square within the number that you're trying to simplify. So this becomes 5 times the square root of 16 times the square root of 2. 5 times the square root of 16 is 4. And then we still have the square root of 2, which cannot be simplified any further. So this gives us 20 times the square root of 2. Working with the 8 times square root of 18. 18 can be rewritten as 9 times 2. This gives us 8 times the square root of 9 times the square root of 2, which also gives us 8 times 3 times the square root of 2. 8 times 3 is 24, and we have the square root of 2. We cannot simplify that one any further. Now you'll notice that we have like radicals. So we're going to add the 20 and the 24, giving us a total of 44. And we're going to keep the square root of 2 the same. Let's try another one like this. Let's do 8 times the square root of 8 minus 2 times the square root of 32. You'll notice that we're going to have to simplify each radical first in hopes of finding some like radicals. The square root of 8 can be simplified into the square root of 4 times 2. Rewriting this, we have 8 times the square root of 4 times the square root of 2. The square root of 4 is 2. Now we have 8 times 2, which is 16, times the square root of 2. Square root of 2. Let's simplify the 2 times square root of 32. Square root of 32 can be rewritten as 16 times 2. And then we have 2 times the square root of 16 times the square root of 2. This gives us 2 times 4 times the square root of 2. And last we have 2 times 4 is 8 times the square root of 2. Now you'll notice that we have like radicals. So we can subtract our coefficients out in front of our radical, and we get 8 times the square root of 2. Remember, once the radical part is alike, we want to keep it the same. Radicals don't have to only be numbers. For example, we can have 2 square root of x plus 5 square root of x. Our radical part is the same, so we're going to add the 2 and the 5, giving us 7, and we're going to keep the square root part the same. So our answer is 7 square root of x. What about 4 times the square root of y minus the square root of 25y? Four square root of y is in its most simple form. We need to simplify the square root of 25y. 25, square root of 25 times the square root of y. We can rewrite that as 5 times the square root of y. So 4 square root of y minus 5 square root of y. Again, we have like radicals, so we're going to subtract the numbers in front of the radical sign. 4 minus 5 is negative 1. Keep the square root of y part the same. Or we can write this as negative square root of y. Let's try this example. 3 square root of 50 plus the square root of 72 plus the square root of 27. Notice that the numbers under the square root symbols are not alike. So let's start again by simplifying each radical first. We can rewrite the square root of 50 as the square root of 25 times 2. And then we have 3 times 5 times the square root of 2, or 15 times the square root of 2. Simplifying the square root of 72. We can rewrite 72 as 36 times 2, which gives us the square root of 36 times the square root of 2. The square root of 36 is 6, and the square root of 2 is already in its most simplified form. So the square root of 72 simplifies to 6 times the square root of 2. Now, taking the square root of 27 and simplifying it, we can rewrite 27 as 9 times 3, which gives us the square root of 9 times the square root of 3. The square root of 9 is 3, and the square root of 3 is already its most simplified form. So square root of 27 simplifies to 3 times the square root of 3. This time you'll notice that we only have 2 like radicals. These are the 2 that we can add together. 15 plus 6, giving us 21. Keep the square root of 2. Don't change the square root of 2. But we cannot add to it the 3 square root of 3 because they are now unlike radicals. So our final answer will be 21 times the square root of 2 plus 3 times the square root of 3. This is the most simplified form. Our last example we're going to do is the square root of 4y cubed plus the square root of y plus the square root of 6y squared. Again, we do not have like radicals, so we need to simplify these first. The square root of 4y cubed can be written as the square root of 4 times the square root of y squared times the square root of y. The square root of 4 is 2. The square root of y squared is y. And then the square root of y we cannot simplify any further. The square root of y is already in its most simplified form. So the middle term is going to stay the same. Our last term we can write as the square root of 6 times the square root of y squared. The square root of 6 we cannot simplify. However, we can simplify the square root of y squared. This gives us y times the square root of 6. We have 3 expressions. two of them have like radicals. The 2y square root of y plus the square root of y are like radicals. It may be helpful to put a 1 in front of the square root of y. Rewriting this part, we end up with 2y plus 1 times the square root of y. You'll notice that 2y and 1, these are not like terms. So these we cannot add together any more than what we have written here. Just like we couldn't add these even if we only had the 2y plus 1 without the square root of y. They would not be like terms. So this is as combined as we can write these. So our final answer is going to be the quantity 2y plus 1 times the square root of y plus y times the square root of 6.